So let's talk about WAN routing. Before we talk about WAN routing, let's have a quick recap of what all things we have learned. We have learned about how multiple PCs which is connected in the same segment in a LAN, how do they communicate. We have learned about CSMA/CD. We have learned about how flooding happens, all of those things. So until now what we have learned about is within a building, when there are PCs connected over switches, how do they communicate, how switches work, how PC gets a MAC address, so on and so forth. So it is all within a specific building or a specific location as such. But what happens when there are devices which needs to communicate across the globe? So like one building is in say San Jose, and one building is in US, and let's say another building is in India. How do we make sure that these devices which are geographically in different places, how do they communicate? So that is where the need of WAN routing comes in. So there are two WAN technologies majorly. I mean, one is Leased Line and another is Ethernet WAN. We will talk more about Ethernet WAN, but we need to kind of touch upon Leased Line also, because that is also something, even though that's not so relevant nowadays, but we will still have a history of that as part of this session. So what is a leased line? Leased line is basically a physical link service, which means when a PC or a device sends bits, it knows and it guarantees that this bit will be sent to the other end where it is connected. So it is a physical link service, and it is actually designed to send and receive bits at the same time. If you remember the full duplex mode, which means at the same time it will be able to send and receive the signals as such. And one of the most important limitation, or one of the most prominent limitation for leased line is it needs physical connection end to end, right? And that is where the difference of leased line and Ethernet WAN comes in, because Ethernet WAN figures out how to route packets and stuff like that. We will learn about that, but right now understand that leased line needs a physical connection end to end for the communication to happen. So how do we make the physical connection? Because as I mentioned, it is geographically distributed places, and they wanted to communicate between geographically distributed places. So how they do is they had something called central office, and what the central office has is the devices which are leased line capable. And whenever you need a leased line, you will ask the provider that I need a leased line connectivity, and the leased line providers make a connection to your office from the centralized or from the central office. So let's say this company wanted a leased line, so it actually goes and connects that building to the central office, and then it actually makes the connectivity work. Now so as I mentioned, this is a physical leased line is basically a physical link service, but there are some data link protocol for this leased line, and there are two major one. One is high level data link control, we call it as HDLC, and another is point to point protocol, PPP. So we'll learn about both of these things, but at high level, this is how the packet format for HDLC and PPP looks like. Let's identify what each of these fields are. The first is flag, then address, control, type, and FCS. What is flag? Flag is basically acting as preamble SFD in Ethernet. If you remember, preamble is basically a little, you'll have some amount of bits already there, which actually tells you this is the start of the frame. It is also used so that if there is any collision or some of the bits are being lost, you don't kind of lose the entire packet as such. So whatever preamble does, the flag does a similar component, similar functions in the HDLC and PPP. Now you may see that in the address part, if you remember, for the Ethernet protocol, there was a source address and destination address, because for Ethernet there is a shared link, and the PCs can communicate at the same time to multiple other PCs, and that is why it needs a source address and destination address. But in this case, it is only address which is destination address, because it is a direct link, as we have seen earlier just a moment back, that the connectivity needs to be end to end directly connected. So there is no need of source address, because once it puts on the wire, all it needs to know is what is the destination address that it has to send, with the next hop destination address that it has to send. So the address part here is the destination address. Then comes the control, which is no longer used as of now. Then comes the type. This type actually tells what is the upper layer protocol, what is a layer 3 protocol. Is it IP, is it IPX, or if it is Apple Talk, what is a layer 3, so that once the packet reaches the next hop, it will be able to send that packet for the processing to the upper layer protocol. So if it is actually Apple Talk, it will be sending to the Apple Talk services. If it is IP, it will be sending to the IP service, whichever is a higher level protocol it wanted to identify. That is the purpose of type. And FCS, as you guys already know, in multiple of our earlier lectures we have talked about it, it is basically used for the error detection. Okay, so now let's see how the packet moves. Let's say this PC1 wanted to go to PC2, and this is a leased line connectivity. That means the the PC1 in whichever building it is, there is a connectivity directly to going to the service provider, and then from the R1 to R2, again there is a connectivity that is again a leased line connectivity as such, and then finally R2 is connected to PC2. So PC1, all it knows is for it to send the packet to let's say it's a high sending by the PC1 to PC2, that has to first go over R1 and R2, and this is how it is actually done. It first sends that packet to R1, because all PC1 knows is for me to send it to PC2 or any other destination, I need to send that packet to R1. Now what R1 does is, the packet, again this will be an Ethernet packet, because from here to here it is Ethernet. So the R1 will have the Ethernet encapsulated packet which is received, and then what it does is it decapsulates the Ethernet packet and it encapsulates with the HDLC header that we just mentioned, and then it actually sends that packet, which is HDLC encapsulated, to the router R2. And once it reaches the router R2, identifies that okay, this has to be destined or sent to the PC2, which is in its own Ethernet segment. So it decapsulates the HDLC and encapsulate it with the Ethernet, and it actually sends back to the PC2. So how does it looks like on a packet header? This is how it looks like. So PC1 sends high, you have the IP packet, and you have the Ethernet, Ethernet header and trailer. So this Ethernet packet will be sent to R1. At the R1, it does an encapsulation, which is it does the first decapsulation of the Ethernet frame that it got from PC1, and then it encapsulates over the WAN using the HDLC header and trailer, right? So the same IP packet, same message gets encapsulated, first decapsulated by the router 1, it decapsulates the Ethernet frame, and then it encapsulates with the HDLC so that it can actually send over the WAN link. Once it reaches the R2, it again decapsulates the HDLC which it received, and it again re-encapsulates with the Ethernet header, and then it actually sends it to PC2. So this is how the communication actually happens in data link in HDLC protocol as such, using the leased line. So in the next lecture, we are going to learn about Ethernet WAN.